Mm. Hello, class. How y'all doing?
Good morning.
Good morning. 10 o'clock. Many people. Got 8 people. All right. Anybody with any questions about the assignment that you had to turn in? Because I think it was due, huh? Let's see. Did I share my screen? Let me share my screen. What is it on? Yeah, your assignments was due on last night at 12 o'clock. Anybody had issues with those assignments? Anybody? Anybody had issues with the tests? I don't know if it was from this class. I know some people called and said they had some issues trying. It was asking them for a password, um, and the way it was resolved was that they had to log in, and I don't know why that was. They had to log in to Canvas from the MyBRCC website. And you then get to Canvas and take the test. So that was one issue that we did have. But outside of that, everybody else, they didn't have any. I didn't have any other calls. So the quick, well, they took a quiz. Your binary quizzes, questions about that. Your octo quiz, questions about that. I know one person in this class said something about they didn't use the hyphen, but I gave you the word bank, so you should have just followed the word bank, word for word or letter for letter. I posted a flowchart quiz, which we're gonna talk about in this class period. I posted a an assignment which allows you to write a paper or really list 20 different commands or C++ reserved words, or we call keywords. Now, this assignment is not long. I don't want you to try to go and grab information, paragraph, pages of information, and put in the document. What I want you to do, I want you to find the commands, read through the command, what they are, and give me a brief description of what that command does in C++. Okay, I don't want paragraphs of information on a command. Because if you look here, it says using Microsoft Word, number and list, all right? Or just saying number like 1 through whatever, and list the name and the purpose. This is the name. See out is a name. You should have seen that command in your previous assignments, but you didn't really, may not have known it was a command or a keyword. Okay, the name and purpose. What is the purpose of this command? Okay, this command is used to display the output to the standard output device, i.e. to the monitor. Okay, so that's what that command does. Anytime you use that in C++, it's used to display output to the standard output, whatever the screen or monitor that you have. Okay, and that's all I want. I don't want no big definition of where it's located, how, why it came about, what. No, just what it's used for, its purpose. And then you do the second one, then the third one. All right. Now, I'm gonna give you a heads up. Sometimes when I give this assignment, student use operators and symbols as commands. Those aren't commands. Like example, plus, minus, divide. That's operators. That's mathematical operators. Okay. The double quote, single quote, the slash, semicolon. That's syntax symbols. That's not commands. Okay. So I want word commands that are used in C++. So hopefully everybody got this. All right, and 20 of them, and I want them listed. I don't want to have to count. I got to count. I don't have to try to count how many you have listed. All right. Where's this? Okay, yeah, I got to count. All right. So anybody with any questions?
Is there a place that you have maybe on your website with like a list of these commands that we can look at, or do we just need to do some Googling?
Right. You could go online and look for keywords or commands in C++.
Gotcha.
And it should give you a whole list of them. All right. And I'll give you another hint. What you can do, I have what I don't have it. No, it's not done. Because for my 193 class, no, I have something available for them. But you can look up or Google reserved words or keywords in C++, and it'll give you different commands. And what this is going to do, hopefully, it'll allow you to see several commands and their purpose. So, and like I say, all of them we might not use, but majority of them we will use, and you'll already have some kind of knowledge of what they're used for. So it kind of just an assignment to kind of get you familiar with some of the C++ command, so you won't be so, I guess, thrown off when you actually see them. All right, or we start going over. All right. What else I wanted to say? But the test, and that's done and everything. I think I got the quiz. Now the quiz is a small quiz. This is just a small quiz of symbols. These symbols are used to create your logical your algorithm for what you're doing. All right. And each one of these symbols have meaning. All right. So let's see if I can, well, now I won't go here. I'll go to my web page. So I'll go back out of this. Let me get back out of it. So I'll go to SYL. Let's see. I'll go here and I'll go to the 1923. And you should see something that say flowchart symbols. See here? Now there's many different flowchart symbols. Even in Microsoft Word, if I pull up Microsoft Word, if I open up a blank document, and if I do insert and I do shapes, and I can scroll down to, see flowchart. These are flowchart symbols, all right? This is one of them we're using. This is another one we're using. This is another one that I know of we're using. This is one, and this is one that we're using in our quiz. But there's many other flowchart symbols, and they all have particular meaning so that you can design something and you can flow through it to understand what is to be done, what's first, what to do if this or whatnot. So let's look at the SYL site and see the commands. All right. So we look at this, and I tell students all the time, if you try to take the quiz without reviewing or studying, I would be able to tell, because some people may look at this and I have different choices. Oh, it's a circle. Oh, it's a square. Or it's a parallelogram. You understand? No, they have particular meaning. And if you don't study it, you won't get the right answer, because they do have meaning. So just study it you study your chart, what these symbols mean, and then take the quiz. Now, the thing is, hopefully you study it to know it, because when we start looking and doing some exercises, you would kind of understand and know what we're doing and what that design actually means. But if you don't, you'll be like, oh, well, I don't understand it. I don't get this, because you never took the time to review the symbols. All right. So, given that, Les, any other questions?
I have a question. Is there any other symbols that we didn't know about besides those symbols you show us?
No, that's it. And what happens is, if there's any, I'll introduce them, as we go through the lecture. You know what I'm saying? Because I know when we'll just talk about it, we're just going to briefly talk about functions, right? And there is a symbol for functions, all right? But like I say, we're not getting that deep in the coding or whatnot in this class. So, we don't introduce a lot of those other symbols, all right? So here we're going to pretty much talk about the design of a program and what all is incorporated in the program, all right? So designing a program, all right? Programs must be carefully designed before they are written. Now, sometimes students don't do this, but it's a good practice to know what you're doing or going to be doing before you get started. It's almost like you're given a word problem. You're given a word problem and you start writing numbers down and doing some kind of computation before you even read through the word problem to know what it is you're looking for. All right. So what happens? You start writing and thinking you know what they asked for, and you get a result, but then turn it in, it's wrong. Then you go back and read through the word problem. Oh, they wanted to do this, that, whatever, which sometimes may totally alter whatever you had done previously. And that's the same thing with our programming. With programming, you want to get a basis. You want to know exactly what the outcome is, all right? Okay, what it is that they're looking for. But then you also need to find out what the process in which you're going to accomplish it. Now, in computer science, in these classes, beginning classes, pretty much we're just trying to get the result. If you can get the result, it's good. But as we continue, it's in computer science, they may give you specifications. Okay, I want this output, but I want you to go about doing it this way. Then I want you to take this and do this, and then do this, and then output it a particular way. So just getting the answer sometimes is not all what's entailed in computer science. It's getting the answer by doing it the right way, and then eventually displaying it the proper way. All right. So that's some of the things we're gonna learn. All right. So you need to be able to know what it is that you need to start doing. Okay. So, and then say after you design the programmer, then you begin to write the code, because you know what all commands you may need to incorporate in this program based on those specifications. All right. So if we look at this process, it says you're going to design the program, okay? So you're going to say, okay, maybe use some pseudocode and say, I need to do this step first, this step second, this step third, this step fourth, this step fifth. And have nothing to do with coding, all right? It has all to do with what? How I'm going to do it. It's almost like, say, if you wanted to build a picnic table. Now, there's a process of building it, but there may be some things that you may need to give a step-by-step instructions of what to do outside of actually building it. What? I need to get my tools, my hammer, my nail, or if it's a drill, my screws, my saw, power, my electrical power cord, whatever. I need to get all that, have that together. And then from that, now I can start what? Measuring and cutting. And it might have a step, okay? Cut out all the legs, cut out all the seating, cut out all the tabletop. And then what? Put together so you have a procedure that you're gonna follow in order to accomplish that task. You're not gonna just start doing one thing and then run into some issues where, oh, I did this, but now I built the tabletop. Now it's too heavy to put on top when I should have just built from the bottom up, and it'd have been much easier. So stuff like that. But then look, in programming, when you write code, and some of you may have experienced this in the program assignment that I gave you, you type everything in, you run it, got an error. You got to go back, check to see where you have your error, fix that error, run it again. Oh, that's fixed, but now I have another error. Fix that error. So you may have to fix errors until you completely get them all out. And then what? The test part is trying to get the executable code to see whatever. So once you get all the errors out, then you get some results. Now, just because you got results does not mean that it's right, because I could write code, add two numbers. The two numbers I add up, I might be getting a different result. When I know I'm adding 2 and 2 and I'm getting 5, I know somewhere in the program it's adding 1 to my value and it's giving me the wrong result. So I need to debug it, modify it. So I might need to go through this cycle multiple times until I get my output correct. Or it might say, okay, you need to output the number 2 spaces below the heading. So now if you're putting it next to it, right after the heading, then it's like, it's wrong. You got the right output in a sense, but it's in the wrong format, which makes it wrong. And an example I normally give students is, if you were the programmer of a company where you was developing this software to print out employee checks, right? So they gave you the number of lines that the check has on it, the spacing for all of the different fields, like maybe the date of the check, the amount of the check, the person the check goes to, the worded amount of the check, and whatever. And what happens is, when you coded it, you made the name, like the person's name of the check drop down and print on the actual worded amount of the check. Well, that could be a problem, because when a person goes to the bank and it has a person name on for the amount, the worded amount of the check, they may not cash it. All right. So even though you wrote the program and it works, the information might be in the wrong place, which therefore says that the program, you didn't write it correctly. You wrote it, it worked to give you all the output, correct output, but the output is not in the proper order. All right. So in designing your program and give you the steps to what you need to know, you need to understand the task of the program, what it's supposed to be doing, and determine the steps that you're going to take in solving that problem. So that would be your algorithm. All right. So that's all it's telling you. You have to understand the problem. And it talks about that here. All right. All right. Determining the steps. Again, what's the algorithm? And they gave an example here of a person, let's see, assuming this person is old enough, to be trusted around the stove. Here are some tasks for, I think it's boiling water. I think this is what it is. So boiling water. So what? Now you need to say, okay, what would I tell a person, or what would be the steps for a person to boil water? So it said, and like I said, you can have other steps in between, because you can say, go to the cabinet and grab a pot, but they eliminate some of that stuff in a sense. But it's like, pour the desired amount of water into a pot. That's the first step. Put the pot on the stove. or on the on the stove burner, all right? But then you turn the burner to high, which would be the burner that the pot is on. Because what? You could turn the burner that the pot is not on, that water will what? Never boil, correct? So you turn it, you actually turn it on the burner where the pot is sitting on. And then you watch the water, to see, the bubbles, that they're rising from the bottom. Okay. And when this happens, what? You've achieved your goal. So, and this is just your algorithm, the steps that it would take to accomplish that task. And programming is the same way. And we'll look at it. So look at this. A program will break down a task that a program must perform in a similar way. All right. An algorithm is created, which is what? Your step-by-step instructions. All right. So it says, for example, suppose you have been asked to write a program to calculate and display the gross pay. Okay. Now, stop right there. Depending on what the type of job a person have, the number of hours that they work, and if they work overtime, and the way the company calculates overtime will have a big impact on what? Your algorithm, all right? But if we just creating a basic or a simple algorithm for calculating the gross pay, the gross pay, not dealing with overtime or whatnot, then it's just a simple what? Get the numbers of hours work, get the value for pay rate, multiply the two together, and then you got what? The gross pay, right? But we know that what? It can be more cumbersome depending on what type work is entailed for calculating overtime, if it's overtime, whatever, and stuff like that. But simply, your step-by-step instructions. All right. So that this algorithm is called pseudocode. All right. Pseudocode can be either written. What it is it's handwritten instructions or just written instructions as to the steps that you're going to follow into accomplishing a task. All right. So that's all it's saying. Okay. And an example, the word pseudo means fake. All right, so pseudocode is just fake code. It's a step-by-step algorithm, but it's not the actual code that is needed to write the program. Okay, so look at this. They say here's an example of how you might write pseudocode for the pay calculating program. Okay, that was discussed earlier. So now, let's look at this logic here. So what happens here in this situation, the employee hours is not known. The employee pay rate is not known. And then if we look at the gross pay, it's calculated and then printed out. So what happens? Even you today, when you use a computer and you go online or you using some software that you have on your computer, in order for the user to know what to do or what to input, they need a prompt. They need something to display on the screen, some type of message to tell them what it is they need to do, whether they need to press a key, whether they need to type in a value, whether they need to do whatever. So click on a certain icon. So look, display. Display is like an action word that says show, all right, to put on the screen. So display, enter the number of hours the employee works. So if we run the program, the user will see, or you should prompt the user, and they should see enter the number of hours the employee worked. Okay, but then what? They should be able to what? Once they see this message, it should have a prompt where they can input those hours. Once they input the hours, then they should be prompted with enter, and like I say, this is just a prompt that they came up with. You could come up with your own prompt. You could say, please enter the number employees hourly pay rate, and you can say that should be no greater than whatever, whatever your prompt is. So it says enter the employees hourly pay rate. So then it should allow you to input the pay rate. But then look here, the word set. Set is like saying, okay, take gross pay and assign it to equal to hours time pay rate. Okay, so whatever this expression equates to, we gonna set gross pay to equal to that. But then look here, after we calculate what the gross pay is, now we want to display the employee's gross pay is, and with the dollar sign, and then whatever that value was calculated to be. Okay? Anybody with any questions right now? Questions? So this is what I'm gonna do. I'm gonna take this and I'll show you how I can write it as a program, all right? Just to kind of make you understand, the pseudocode is not the actual code, all right? All right, so I'll move this over and I'll make it a little small. You won't see it. I can see it somewhat, and move it over. So what I'm going to do in Visual Studio, all right, so what I'll do, this is, how would I tell you? I'm going to tell it to you like this. Okay, example. See this example here? I'm going to take this out too. This is an example of a shell that I normally tell the students to create before they start their program. Because if you create this shell here, all right, you know that you have pound include, which is your out stream, which is going to allow you to input output. You have your using namespace, STD, you're loading the standard library. Then your main function, this is your header file, int main, and then you have your function body. So this is set, and if you run this, you will get nothing. All right. If I debug this, it'll get me nothing. But I know that what my shell is written correctly. All right. So I don't have any errors. So now all I need to do now is look at this logic and try to put it together. Now, when you're coding, all of a sudden now we need to introduce variables, okay? What is a variable? A variable is could be a named reserved area in the computer, that you give so that data can be stored. Example, we know that we need to input hours, HOURS. We know that we need to input pay rate. We know we need to calculate gross pay. So those are variables that we need to allocate so that the computer can know to use them. So what I can do something like float. Now we'll go over this a little later too. This a variable has to have a data type, okay? What's a data type? A data type is the type that's used to determine what type data a variable will hold. What are the types? You got alphabetic data and you got numeric data, all right? You got integer for numeric data and float. Integer data is whole numbers. Float data is the numbers with decimal places. And then you got character data, where you can have a single character, or you can have, then you got string, which is no character, or you could have a character array, a series of characters. So we're going to use float, and we're going to declare hours, pay rate, that's what it had, and gross pay. So when I do this, now I can use these variables in my program, and the compiler will know that, hey, hours is an allocated memory location, and I can go and either put a value in it, or I can read data from it. So I've created my variables. All of them are unknown. So and now I need to tell the user what to do. So remember that command I used in that assignment, cout. Cout does what? Prompt information to the default output device, which is our monitor. So I'll say cout, and I can use their same expression. Enter the number But look what happens. I have to know how to write this code. I'll reduce this a little bit. Let's see. All right. So if I have entered the number of hours, look, this just say display and in double quotes this, because I'm telling it what I want to write in double quotes. But this is the actual command in C++ that C++ understands to what? Output it. So this is just pseudocode over on the left. This is the actual C++ code. So if I'm going to prompt the user to do something, now I need to allow them to do it. So now I'm going to introduce another command, and notice what's happening. The directory is going the other way, hours. Okay, and now I could put hours here because what? Hours is a variable that I did allocate. If I change that name to hour, I'll get an error because what? Hour has not been declared anywhere in the program to say it's a valid variable I can use. So I'll make it hours, all right, because it's what I want to use. So now the next one is is display. So I'll do cout. And notice the directives are going into the cout and enter the employees hourly pay rate. All right. Now we got to what? I'm gonna prompt them. Now I need to allow them to enter it in. CN, oh yeah. I was wrong way. CN pay rate. Now I'll show you something. If I take that capital R and make it lowercase, it's an error. C++ is case sensitive. The compiler, everything is case sensitive. My commands, case sensitive. Any words I use, variable names, whatever, is case sensitive. So if I use uppercase, I have to use uppercase to match whatever I'm referencing. All right. So now I've inputted the hours. All right. Prompted to input the hours. Prompted to input the pay rate. So now I need to what? Set gross pay equal to hours times pay rate. So gross and capital PAY is equal to hours times pay rate. Right? So now you might look at this and say, okay, this is a mathematical expression, all right, where gross pay equal hours times pay rate. Now, you might say, well, in math, I could switch just around and say hours times pay rate equal gross pay. That's a no-no in computer science. In computer science, you always solve for the expression on the right-hand side and assign it back to the left, always. I don't care where, what, how, always. solve on the right, assign to the left. If I see somebody doing this and this writing this code, and they do something like this, I would ask them who was their teacher, because no computer science expression will ever solve this and assign to the left. I mean, assign to the right. You always solve on the right and assign to the left. Okay? Just keep that in mind when you start writing code. Just keep that in mind. Now, I'm calculating the gross pay. All right, set gross pay. Now I want to display my output. So now to display what? See out and what? The employees gross pay is in $sign. All right. And what I'll do, I'll put a space, because I like to put a space here between my answers. All right. And then I'll put not a comma. You put a comma in the pseudocode, but here you want to stream the next output value. All right. And then I want to output gross pay. All right. And then I might do an inline, NL. All right. NL just to make the cursor go to a new line. So what I'll do here, and I'll do a new line at the beginning too. And all it's doing is just dressing it up, but it's the code. So we look at this, but then we look at this. So let's run our program, all right? And this is the program. So let's run the program, debug, and I ran it so I could just debug it. So if you notice what happens, it says what? Enter the number of hours the employee worked. And now I'm gonna put just some small numbers. I'll say he worked 5 hours, all right? But notice, I like to put a space after this. I didn't do it here. Hit enter pay rate. Like I said, I like to put spaces where it's more readable. Okay, I'll say 10. So we know that 5 times 10 should give us what? Should give us 50. So when I hit enter, see, the employee's gross pay is $50. All right, so run it again. Now I'm gonna use some decimals, but what I'm gonna do first, I'm gonna put the spaces to show you how it looks a little different when you add those spaces at the end, Now, so let's debug it again. All right, so now you see that what? There's a space, so now when I type a number, it's not right next to my prompt. So I'll put a 5. And then here I'll say 10.5, all right? Or I'll say 10.13, all right? And hit enter. And this is my pay. And notice it have the decimal because I made it float, all right? I was able to put a decimal value here because it was float. Here, I put in a whole number, but it takes a whole number and just convert it to float, which is 5.0, all right? So that's how you would take pseudocode and create the program. So let's go on to the next step. It talks about flow charting. Anybody got any questions about the conversion of the pseudocode to actual code? And like I said, it's going to take practice and whatever, but if you understand, if you followed along, good. All right. Any questions? Any questions? All right. But don't be afraid to ask now. Here we go. Flow charts. All right. Flow charts is another tool. Flow charting is another tool that programmers use to design their program. A flow chart is a diagram that graphically depicts the steps that it takes that takes place in a program. So the pseudocode was what? English-like instructions. The flow chart's gonna be the actual graphical design, right? So let's do this. Or let's say we go through this. It tells us we need a start and a stop terminal. Okay. That's the if I go back to I still have, yeah, I still have this. All right. Flow charts. What are my flow charts? Flow chart. All right. So we need a start and stop terminal. So this is the terminal symbol. All right. To start the process of a program and to stop it. Okay. So when you write a flow chart, you should have this to begin, and you would have these little words begin or start in it, and then you would have this symbol at the very end, which should have end or stop in it. All right. So it talks about the start and stop symbol. All right, and we'll create that. But then you have other symbols that will be used. So look what they did. They wrote the actual flow chart showing what the process is for this program. Now, minus one step that I say should be in there is correct. All right. So look, start terminal. All right. Then what? You got display in a number of hours work. But look what type symbol it's in. All right. Then you got input hours work. It's in the same type symbol. And then you go on, you got all these four are in the same type symbol. Now, some students might say, well, Mr. Vessel, could we put all of them in one big symbol or parallelogram? I would tell you, yes, you can, but if you do, make sure they what? In the proper order, okay? So if you put them all in one, make sure they're in the proper order. But to make your logic much clearer, separating it, you can say, okay, this is a command, I'm doing this. Another command, I'm doing this. Another command, I'm doing this. Another command, I'm doing this. All right. So it breaks it down a little bit better. All right. So if we go back to the symbols here, the parallelogram is a symbol that's used for input, but it's also used for output. The key to this is to know if your input and output would be your action word. Okay. The action word here is what? Display. Display is what? Output. If I say display, if I say write, if I say show, those are action words to display. All right. To output. If I use something like get, if I use receive, all right, something like that, that's like input. Okay. So here are input. So here would be your inputs. This is an input symbol. All right, where data is being inputted, and this would be output, where data is being outputted. Okay, again, display, input, output, that will be output. Okay, so that's those symbols. But then you get down here, and then you see set. Okay, set would be a process. The computer will have to compute or calculate something. Anytime you're assigning a value or how would I say it, or calculating something, that would be set or process. Anytime you're declaring a variable, that will be a process. All right. So that would be what? The square or rectangle shape. All right. So if we go back to the notes, the here, okay, the rectangle is the process symbol. All right. Then we have, this is an off-page connector. What this is used for is if you on it working on a page and you run out of room to continue your flow chart, you just use this off-page connector. You put a reference value here, like the letter A or the number 1, whatever it means, or it could be AA. And then wherever you starting on the next page, you put that same label or reference, and it knows that it goes from this page to that page because what? The arrow flow of where it's flowing down to the next page. All right. Just like with your arrow here, you know that your program is flowing in that direction because of the arrow. All right. And this here is a decision symbol, which we won't get into not quite yet, because we're still dealing with the basics of just step-by-step instructions. But the decision symbol introduces the if command or the while or the do. All of a sudden now you're gonna be able to or have to branch off depending on what an expression is. Example, in a decision symbol, it might have if X is greater than 5. Okay, so if it's greater than 5, then you would have a yes arrow going to steps to follow, or you would have a no arrow and you'd have steps that you need to follow, all right, to get to the end of the program. All right. So, but we're not at that point yet. So the set would be, and you're assigning or setting gross pay to equal to the expression of hours time pay rate, which would be this a process symbol. But then what? We displaying our the employee's gross pay is $ and whatever the gross pay is. Okay? And we end it. So the end terminal, remember? End terminal. Now, if you look, your arrow flows. You're starting, it flows to this one, then it flows from this one to this one, 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 and you eventually ending your process. Okay, so that's basically it. And like I said, the only thing that I would have added would be my a process symbol up here, right before here, that has float hours, comma, pay rate, comma, gross, because it would be a process to where you allocating space for those variables so that they can be used in the program. Okay, so that's all. Other than that, this would be the flow chart. So the flow chart, the pseudocode, all right, and then we had our other instructions. Do this, all right. Get the number, the actual written language in pseudocode, and the actual pseudocode that says do this, do this, do this, do this. All right. Anybody with any questions? Hello? Questions as to how the flow chart was written, why it was written the way it was written, whatever.
No.
Okay, all right. So long as you're understanding the flow. All right. So now, all right. So you could go through your checkpoint, and like I say, you normally see that again on the test. All right. Output, input, and variables. Now I just introduced you to variables in the program. I also introduced you to output, which was the C out statement, and input where we use the C in statement. So when we deal with output, as information going out from the computer, whether it's to not the computer, from the program, whether it's to a file, to a storage location or whatnot, okay, or to the screen. Input, that's information that's been the program wants to receive so it can maybe do calculations, store it or whatnot, or compare it, all right? But also variables. Now, the variables we used in the previous program was hours, pay rate, and gross pay. Now, like I said, a variable is a programmer defined, and you will see that later too. Programmer defined identifier that's used in the program, and it's have an allocated memory location to hold a value. All right. Now, there are some rules in naming variables. Okay. One rule is, notice they got the variable called hours. I'll say pay rate. One rule is a variable or a user-defined variable cannot have spaces in it. So say I wanted to use pay rate and I did something like this, pay space rate. It's going to be wrong. The compiler is looking for either pay to be a variable and then comma, rate will be a variable. You understand? Because I have a space in it. I can't have a space anywhere in my variable name. I can't have P and then a rate. I can't do that. It got to be one word, which means a series of characters. Okay? It could be one character, right? But it got to be one or more characters, right? Now, the second rule is it cannot begin with a number. So I could have pay rate and I could put any number I want here. I'll put 5. I'm gonna get an error because that number cannot start the naming of a variable. Remember that. And class, this will go from now on in that C++ until they write a compiler that changes it. But this is the rule. You cannot begin a variable name with a number. And now you say, well, who would want to do that? Why would somebody do that? Well, if I told you to write a program to input 3 numbers, and I didn't give you any rules about variable names, some people may write 1 number, 2 number, 3 number, right? That's a valid assumption, all right? But you won't be able to do it that way. You would have to do something like this. And I'm just using an int data type. You say num1, num2, num3, all right? That would be valid, all right? But I cannot say 1 num, 2 num, and 3 num. You understand? That will not work. You cannot begin a variable name with a number. All right. So another rule for naming your variables is you cannot use special characters, right? Class, these just are written rules, all right? You cannot use special characters. So say I have hours, and I'll put a apostrophe. Can I do it? If I put an asterisk, can I do it? All right. If I put the ampersand, can I do it? All right. If I put the @ symbol, you see, those are special characters. You cannot have a special character incorporated anywhere in the naming of a variable. Okay. The parentheses, curly braces, none of that. Question cannot have those special characters. Now, you can use hyphens, all right? You could use the hyphen. Let me go back. Let me go down. You can use
slashes, like 4.
no, you can't use slashes.
Okay.
Yeah, no, can't use them. I thought you could use a hyphen. I thought you could use the hyphens. All right, but some applications let you use the hyphen. Underscores are valid. Okay, I can use underscore. All right. All right. So I can use underscore. No problem. All right. Now, an underscore can be used anywhere in the naming of the variable. Right. Whereas what I'm saying is I can have underscore hours. That would be valid. But then I'd have to make all of these underscore hours. All right. Underscore hours. So I can do that, but you cannot use any special characters. All right. But you can use the underscores, and in some applications, you can use the hyphen. All right. So those are the rules. Right. So let's look at this. Computer programs typically perform the following steps. So when you write a program, You might have a specific task or purpose you write in that program, but most often, oftentimes, you're going to be writing code to either input, which will receive information, process that information, and then maybe output that information. All right, that's what computer programs does. If you could take a vending machine, you might say, well, what you mean? How would you say it's a computer program, a vending machine? Okay, what? First of all, it displays the digital ones. It displays a message, like say enter the amount or whatever. So what happens when you drop the coin in? You're doing what? Inputting. The computer, which is the vending machine, is receiving your money. Now, once it receives it, it may have to do some process. It will have to do some processing. It takes the money, it evaluates it to see what amount it is, and based on what amount you put in, it may tell you that, oh, you need an extra 50 cents. So it had to do what? Some processing to say the item that you're choosing is $1. You put in a quarter, so you need to put in an extra 25 cents. All right. So that's processing. Then the output, once you select your particular item, the output is, okay, you selected A5. A5 says, okay, go on and press or activate that particular gear to make it spin or do whatever so that it can output and give you your product. All right. So any type of device, microwave, whatever, input, process, output. The microwave, you input a time, it processes that time to warm your food or whatever you have, and then the output would be the output of the countdown. All right. So, and also the generation of the heat to heat your food. All right. So that's what a computer typically does. But within that is many different things going on inside a computer program. All right. So it's just showing us here that what happened, we inputted what? Hours worked. We inputted pay rate. Then we had to process what? The pay rate times the hours worked. And then we outputted the what? Gross pay. So it just did a breakdown of the little program that we did. And it says, okay, well, what was the input part on that program? We inputted hours worked. We inputted pay rate. Process, we multiplied hours time pay rate to get the gross. Now the output, we could also say that the output was also what? Not just the gross pay, but what? Who could tell me what else we could have said the output was? Our what? Our prompts, remember? Remember in our prompts? That's output. Display, enter the number of hours of work. That's a prompt that's going to the screen. That's output. All right? Prompt, enter the number of employees' hourly pay rate. All right? That's output. It's a prompt. Then we had a prompt to say what? The employee's gross pay is $. Okay? I didn't cut my phone off. So those can be considered output also, correct? Those can be considered output also, all right? But what it did, it just took pretty much the variables and showed you the process of it working with the variables, all right? All right. Displaying screen output. And we know what's the command to display screen output? What command we use in C++?
See out.
See out.
All right, see out. All right, see out. Now, I want to show you this pseudocode. And like I I said, you're gonna have an assignment similar to this, okay? Now, if you look at this pseudocode, what does it say? Display Kate Austin. Display 1234 Walnut Street. Display Asheville, NC, North Carolina, 28899. Now, what would be the command that we were going to use in C++?
See out.
See out. So I would have, if I wanted each one of these to be on a line by itself, I could do a see out. And what would I have to put at the end of this? In order for my character turn to go to the new line.
Semicolon.
Say, well, but what command I'd have to use? If I wanted to display Kate Austin, display this and display this, but each on a new line, what would I have to do at the end of each one of them? Anybody?
You'd have to end the quotations, right?
You telling me if I just do, see how, anybody? Oh, I didn't put in quotes. Anybody? Y'all still thinking on what? Still didn't put it. All right. I'm gonna put my double quote. All right. So display, see out. Display, see out. But what? A see out command has a semicolon, right? At the end to say that at the end of the line or the end of that command, that statement. But if I run this, what's gonna happen, class? What's up here? I have my output. It's all what?
It's all on one line.
It's all on one line. So even though I didn't get any errors or it printed out, but that's not anything that's readable or useful to what? To a user. Because what happens is you could have something here where it's another name right here rather than a street number. So, and then you wouldn't be able to determine if something was Kate Austin or whatever. And right here, you could have something here other than street, and then this adjoined to it. You don't know if that's a part of the street name here or the city here or whatnot, right? So it makes it confusing. So how can I print each one of these on a line by itself? Anybody? Yeah, did y'all do my assignments? What is this? What does this do?
And line. So start a new line.
All right, it starts a new line. So if I do that on each one, right? What happens? And this will be the end, which really don't matter, but we'll do it. If I debug it now, look, Kate Austin, 1234 Walnut Street, Asheville, North Carolina, 28899. Correct?
Yes, sir.
Yes.
All right, everybody got that. Good. So that's a part of coding. You got to be able to design it or output it the way it needs to be output. You could get the right answer, but getting the right answer is not the only thing. You have to make sure it's presentable and it's usable. It's almost like taking notes. you could take notes, but if you don't write legibly, right? When you go to study your notes, you all confused. So you went through the process, but you still don't have a positive result because what? You just wrote stuff down and scribbled, and now you can't understand it. All right. And the same in programming. You wrote the program, you got all the errors out or whatever, but now you have the output, but it's too hard to try to decipher what's going on in your output. So you want to make sure your output is clear and understandable by the user. All right. So looking at that, and notice what happened. They say, okay, display Kate Austin, display, the address, display the city, state, zip. Now look here. This is the little program. I wrote the program showing you what it looked like, right? But they just showed you this part, right? This is the pseudocode, all right? Then display this, then display that on a new line, display that on a new line. And this is the output, which is the output from what we got. All right? So now let's look at the flow chart. We're starting our program, and look what? Input output symbol, display Kate Austin. Input output symbol, display Walnut Street. 1, 2, 3, 4 in Walnut Street. Input output symbol, display Asheville, North Carolina, 28899. Then in, and notice your arrows. Your arrows are important. Okay, that's the flow. That's how it's flowing. All right. So this structure, and look at the bottom what it says. It's a sequence structure. Now you might say, well, why is it sequence structure? What does sequence mean? If I tell you to write something in sequence, what does that mean? What does it mean if I say write something in sequence? That means in the order or the steps that it took to follow, step by step by step by step by step, not diverting from that. It's just one after the next, after the next, after the next. So if you look at this flow chart, what? It's going here, performing this. Going here, performing this. Going here, performing this. So what? 1, 2, 3, 4, we finished. That's sequence. 1, 2, 3, 4. We're not branching off to do something. We just going one step after step after step after step. That's a sequence. All right. So it tells us what is that? Here. A sequence. It is mentioned earlier in that statements in program 2.1 execute in the order that they appear. All right, from top of the program to the bottom. This is a set of statements that executes in sequence. All right, so let me change this view right quick. Enable it. All right, in the order, which is called a sequence. All right, so now a structure, because there's two other type structures. A structure is also called a control structure, all right? Whereas we have what? We have the sequence, we have the, I forgot what it's called, the if logic, and then we have the loop, all right? Conditional, and then we have the loop, all right? So now, let's look at string literals. String literals is just information that's encapsulated in what? Our double quotes. So when we look at this program here, this is the string literal. A string is a series of characters, right? So this string is KATE space AUSTEN. That's the string literal, all right? Variables and input. We talked about the variables and we also talked about inputs. You can read through this, but we're basically talking about what? Input hours, where we did what? CN the hours, all right? And before I go, I want to show you the program that I want you to write. It's a small program. All you're doing is outputting these 3 statements, but I gave you specific instructions. Not a lot, it's just one statement, but that you need to follow. And you need to, if you don't know you need to research. Because what's going to happen, some people going to get it wrong. And when I'm going to take points off, and you're going to say, well, oh, Mr. Sylvester, but I thought, nope, you should have did the research. But then too, some people do the research, they read through it, they understand it, but then the program doesn't do what they research. That happens too. All right. Oh, well, I just misinterpreted. I thought, no, it's wrong. Okay. So make sure you understand it. All right. So we talked about variables and we talked about, okay, look at this program, display. That'll be what? See out. What is your age? All right. Input, age. So we know what? We're going to have to declare a variable called what? Age, right? And now age will not be, well, it can be, but it's not a float. It's going to be what? A whole number, so we can make it int. So input age, then display. Here is the value you entered, and then what? Display the age. All right. So what is your age? Question mark. And what they had at the end of here to make it go here would be in line, and which would allow you to prompt you for the age. And then here is your the value you entered, new inline, and then display this. All right. So that's how I would get this to go on a new line. All right. And that's what we're just talking about it. Now here's the flow chart. Flow chart, you start, display, what is your age? Input, the age. Display, here is the value you entered, and display age. Now remember in the previous program when we did the gross pay, it said what? Some to the effect, your gross pay is, comma, and then gross pay, all in one input output symbol. But look here, they just broke this down where you put your prompt and then you output your age. So you understand? So it's no right or wrong way of doing it, but as long as you keep it in its logical order. All right. Variable names, we talked about variable names and we talked about what they must be. Look, must be one word. All right. No, what is this? Should be no special characters. Good. Let's see what it say. Character. Right. And most languages, the first variable cannot be a number. So those are those steps are either procedures that you got to follow in naming variables. All right. And all these are valid. Look, gross pay, it's one word. Doesn't give it a number. Doesn't have special character. Pay rate, one word. No special character. Doesn't begin with a number. Okay. Hot dog sold today. It's valid. One word, no spaces, doesn't begin with a number, and no special characters. All right. So you understand, you can create your variables any kind of way you want. Look here, I could have said hot underscore dogs underscore sold underscore today, valid variable. Or I could have said capital H underscore capital D underscore capital S underscore capital T. All right. So it would have been valid. So either way you do it, it's valid, long as it follows those rules. Uppercase and lowercase doesn't matter, long as you make sure you reference it in that same manner. Okay. So that's what they're talking about, the variable names. Okay. Now, displaying multiple items, okay, with one display statement. Now we did that with the gross pay, remember? We did it. All you had to do was what? Use, like say here, I can take this out if I wanted to. One see out statement and what? Just use stream. And that will work. It will do the same thing. And all I did was took all this off to use one C. Oh, it's time class ended up. All right. So that's one see out statement. Now watch. We ran it earlier. Let's run it now. See, got the same exact results, but what? Everything is what? One long cout statement. I would tell you sometimes you may not want to code this way because if you get an error somewhere in this, you have to look through the entire statement and it's going to say line 7. Or whereas if you break it down, you could probably, it might say 7, might say 8, might say 9. So now you know exactly what line your error on and it reduces the amount of line characters you have to check through. All right, so class is over, but before we go, let me go back to the course. Let's look at that assignment that I told you have. All right, here, a weekend assignment. Due by next week. Look what it says. Check it out. Submitted program should execute without errors. Don't submit something with errors. We went over that in the lecture, so you'll be able to go back and look at the lecture for reference. It says, write a C++ program that will output your name, first and last, your major, and the current semester. Okay? And this and it shouldn't be spring 18, it should be spring 2021. Now, look at it, look what it says though. Triple spaced. Now, off the top of your head, you might know what triple space is, or you may not. Regardless, you should research it and then apply it. Now, the researching part might be easy, but applying it to C++ might be a little different. You might say, oh, well, it says 2. Oh, well, it says it's 3, whatever. So what is it? So you're going to have to determine what's triple space and what's not, right? And I'll be able to determine it because I know what it is. I know, and like I say, if you do it and whatever, you're gonna get it wrong. I'll explain to you. This is not triple space. This is double space. Or this is not triple space. This is quadruple space. Or whatever it may be. But make sure you research what triple space is, and then write your code accordingly. Questions?
When we research triple space, should we be researching what is triple space in like C++?
No, triple space is triple space. It's almost like triple space deals with a document, right?
Okay.
Normally when you're writing a document, correct?
Yeah.
So you can just say, what is triple space? Right? Correct? And what that say? Leaving 2 blank lines between lines of a copy. Right?
Gotcha. Okay.
You got what I'm saying?
Yeah.
So now when you write your code, you're gonna have to understand that. But some people they don't even try to research, and they say, oh, that's triple space, or that's 3 spaces, automatic off the top of their head. But then when I grade the assignment, oh, Mr. Vest, I could do it. Yes, you can do it, but I gave you ample time to do what? Research it. I gave you ample time to write the code. I gave you ample time to look at the code to make sure it's correct, right? So some people, what they'll do, they'll wait till the last minute and they'll try to hurry up and put it together and get it wrong. Like I say, but that's not my problem. I'll give it to you. I'll give you ample time. And like I say, I even answer questions. I ain't gonna answer the question specifically, but I'll guide you to, getting it right. Everybody got that?
Yes, sir.
Right? All right. So work on my assignments and everything. And like I say, read up on the notes and stuff too, to stay abreast. All right. So I'll talk to y'all on the next class period if there's no more questions. Anybody have any other questions? Any other question? If not, like I say, have a great day, great week. And like I said, be safe. Okay? Hello?
Yes, sir. Thank you.
All right, have a good one.